Hello everyone, today we'll talk about the problem maximum score words formed by letters. We're given a list of words, and we're also given a budget for each letter, how many times we can take that letter, and every letter is worth something, sort of like in Scrabble. We want to take words from the list of words, such that they can be formed by our letters, we don't use any letter too many times, and the sum of scores of all the letters that we use is maximum. Right? For a given letter, the score is given at the beginning. There are 26 scores then. And we have to maximize the sum of scores of all the words that we take. Just like in the last few days, this problem is based on just enumerating all the possibilities, filtering out those that are not allowed, and taking the one that gives us the best result. So the best way to understand it is just to look at the code. Since we have some letters available, it'll be much more convenient for us, instead of having a list of letters, so sort of like a list of Scrabble squares, to just have a list for all the 26 letters, how many of those are available for us. Now, since we want to index into this array, we're using Python, then we want to transform a letter to which letter it is from the beginning. This is the same way of indexing that is used in this score array. So this is just the ord of the given letter minus ord of A. So for A it's 0, for B it's 1, and so on. So we just get a helper function which we call ix for index. So first we go through all the letters that are available for us, and remember that, well, this letter is available one more time. In previous problems I tended to use non-local variables to store the result. Here instead I will write perhaps the more intuitive way, where the function returns the best result that's available. So I want to have the function go, such that if we run that function, it will give us the answer to our problem. We will recurse, so call the function go again later, after taking some words away from the list of possible words. And you want to make it so that this will indeed calculate for all the words the score of the best choices that we can make. And so the idea is simple. If there are no more choices to be made, then the result is 0. Right? So we just return 0. Otherwise, we take the next word. At the end, we have to remember to return that word again to the list of possible words. But for the duration of this execution, this word doesn't exist, which is why our recursion will stop. And we have two choices. One choice is not to take that word, which we'll look at later, and the other choice is to indeed take that word. And if we take that word, we get to our result the sum of scores of all the letters in that word. And also we do not have those letters available, so for each letter we have to decrease the number of available letters of that type. And after all that, when we return the word to the list of words, we have to fix the availability, because now we have those letters available again. And now, if at any point some letters were used too many times, so now for any letter that should be available, it has a negative number of occurrences, then we cannot take this word. So the result is 0. And we break. And in Python we can write for else. That else means that, of course, we haven't broken out of the loop. Not having broken out of the loop means that we can indeed create this word. We have enough letters. So we will try to now use all the remaining available letters for all the remaining words, get the best result there. So this is this recursive call to go, and add it to our result. So that's one possibility. And also we can just not take that word. So after fixing everything up, in lines 26, 27, we will just recurse on all the other words. So avail is not changed, and there is one fewer word, so we just recurse. And of course we take the maximum of what we got previously, which is either 0 or the scores of all the letters in our word, plus what we can get with the fewer available letters, or what we can get with all the available letters for the other words. So the maximum of that is the result, and this is indeed what we return. So this is the same schema that we used in previous problems.